All right. Thank you very much, Mr. Marufu, for this opportunity. Welcome, guys. It's gonna be an interactive session. This is a tutorial, so we need also to make sure that you contribute very much. All right. So, how are you guys?
We are fine, sir. How are you?
That's good. It seems as though you are the only one speaking. It's Angota.
Right.
Yes.
Yeah, it's okay, right? So, database design and implementation. So I think I've got. Just want to start with this statement. Are you all seeing my screen?
Yes, sir.
Yes.
Yeah. Okay. Right. So the statement is like computer systems and telecommunication technologies have revolutionized the way organizations operate. For an organization, irrespective of size, to succeed, it has to embrace information technologies. Right. So the issue here is that we are now living in an information age. So information is everywhere. So for you to, for an organization to succeed, it has to embrace information technology. So what are we saying? We need to understand from you guys, right? This is databases, right? Where have you ever seen database systems? The applications of these database systems. Where have you ever seen them? Hello? Is it the first time to hear about database systems?
Maybe without knowing, I think I have seen one being used in the supermarkets.
Right, okay. So in the supermarkets, you have seen the databases. That's the reason why I said, irrespective of size. If you start a business today, maybe of selling yogurt or selling maput, you would say, I need a system, or maybe it's a team operating system for you to be able to be selling your things, to account your stocks. So in supermarkets, yes, there are database systems there. What else?
Schools have got databases.
All right, schools. Let us all talk. This one is an open question. It will give me energy to kickstart the tutorial. Please, let us all talk.
Targets by I think functions for database.
Antiga. Yeah, so what you are saying is that this should be an interactive session. Please, let us all talk. Targets, Paloshadisachi, Palotua, a database system, Popai. Where else? Right? Wakambupinda even Muma hotels, aren't it?
Yes.
Right, okay. So let us go straight to the definition of terms. Right, what is data?
Data is just raw facts or unorganized information.
Okay, raw facts. What about information?
become data that has been processed.
Right, what about the environment?
Environment, I think it then looks at where the data is being processed.
All right, where the database is being what? Designed and developed. All right, what about an entity? Guys, I'm going to edit relationship diagram. Hello, Chapesana.
So would you kindly repeat the question? I missed that one.
All right, I'm saying what is an entity? Or you can give an example.
Can I try?
Sorry?
Can I try?
It's fine.
An entity is anything that an organization wants to record something about. For instance, in a company, a company might want to record something about an employee. So an employee would be an entity in the organization.
Okay. So in simplest form, it's just a unique object, right? For example, a person is an entity. A place can be an entity. A location can be entity. And so in an organization, if it's an order processing, obviously an order becomes an entity. If it's in a bank setup, an account holder becomes an entity. The account itself becomes an entity. And what about the attributes?
An attribute describes an entity.
Okay. All right. So,
which
all right, so we are
describes
saying, for example, an entity person. What are the attributes of the entity person?
name, age,
Name.
Date of birth.
It's okay.
Gender.
That's good. So let us move on to the record.
A record is a group of attributes or fields, data items needed by a particular entity.
Right, okay. So what's the difference between a row and a record?
When we are in database, the row is the record.
Yes. So I just wanted that answer. Right, okay. What about a file?
A file is composed of a number of tables or databases.
A file is what?
A file? Really? I think I'm lost today. I said a file, it is made up of a number of databases.
Right, okay. Can you give me an example of a file?
Maybe a file is a collection of records.
All right, okay. Collection of records. Can you give me an example of a manual file?
You can say a student file.
A student file where you will be, if it's a manual, you will be keeping the what?
Like maybe their registration forms, they come and then I put there, when they fill in, then I put a file which is student registration forms.
All right, the ID numbers, the birth certificates, and
yes, yes,
right.
yes.
What about an electronic one?
That's the one that we keep online, or even in our machines.
The file now we give a name, isn't it? So when we give it a name, we say student file. So in that student file, I will say, so we can we say it's a group of records? Then I can have like student Alex, John, Peter.
Yes,
all
yes.
Saved,
So file
under
becomes
one
the group.
file.
Yes, so it becomes the what? The group of records. Right. What about the database itself?
The difference now.
What is the database?
I think the database is when you have different files that relate to an entity. Say, you can have a file on students doing database management. Then you also have another file of students who are doing maybe mathematics foundations. So a database is a way to put all that information in one place. That's what I think.
Okay, so in essence, the database is an organized collection of data and a collection of well-related data that can be easily accessed and managed. Right. So now we need also to understand now the difference between a database and a file. What's the difference?
I think in a database, records are organized and they can be accessed using a key field. But in a file, I think we can just store. Randomly.
Okay, it's fine. So we are going to talk about that one later. All right, what is a database application?
Is it not the program that we use to keep our databases?
Sorry?
Does it not relate to a program in which we used to keep our databases?
All right, so it's an application developed by programmers now, which we use to manipulate data in a database. So it becomes an application, and so it's a developed application which we can use to manipulate the database. All right, so I think I would need to understand the background of you guys. Are there any programmers, database administrators in this group?
Yeah, I was once a database administrator, and at the moment I am also maintaining, it's a school management system called ADADMIN, where I can get into the database, just editing queries, but not creating anything.
Why not creating anything? So are you saying if you get new enrollment, you don't create in the database?
I can actually register. I can create a record.
Oh, so you can do an insert.
Yes, I can insert, I can amend, like changing.
Yeah, okay. All right.
Yes.
So I think you are going to be very instrumental in this tutorial. Anyone else? Don't be scared, guys. Anyone from IT, all right?
Almost everyone here is from IT.
So why are you scared? Everyone is from ICT. So that's good news. Right, it's fine. So it gives me image now.
I also manage our databases, but very unfortunate that my network today is a bit hectic. But I also work with databases for our online servers.
All right. It's fine. It's fine. It's fine. It's fine. Okay. So, our next aspect now is DBMS. What is DBMS?
DBMS is the database management system.
What is database management system?
Right, I think this one now is the actual application which enables us to manipulate data in a database.
All right, so this one is the software which enables you to define, to create, organize, to update, manage, and administer the database, like what we have said, to say in an event that you want to maybe to add tables to the database, if you want to define maybe the procedures and whatsoever in the database, the stored procedure. That's the software which we will be using. Right, okay. Now, I just want you to go now to, I just want you to differentiate between the DBMS and the file system. What are the differences? Hello.
Hello.
All right, it's fine. All right, let me rephrase the question. All right, obvious, the difference they may come as a result of the functionality and it. So what are the weaknesses of a file-based system as compared to DBMS?
Information is not as easily accessible in the file manual system as compared to the database management system.
If you are saying it's not easy, or you are saying it's not easily accessible, why? Why is it not easily accessible?
Okay, I was saying in the manual system, it's not, information is not easily accessible. As in, if you want to locate a file on, say, results for...
Not manual. Sorry, not manual. I mean electronic file-based system as well. Yeah, the weaknesses
as compared
of it. to the DBMS. Because by DBMS, remember we said a database is a collection of related and data.
Yes.
And this one we are saying is just a grouping of what? Of records.
Right. I think with the database now, I think the querying method are actually easier in a database than a file. I'm not so sure, but a file doesn't contain a querying method. A file doesn't contain querying, but a database it has.
Yeah, with the databases, yes, you can query, but with file-based system, yeah, it's difficult to query. But these days, now that we have got analytics, yes, you can do that, but after a long struggle. So obviously, you need to make sure that you come up with some algorithms to make sure that you'll be able to query a file-based system. So we are saying in terms of querying, yes, it's easy with DBMS as compared to the file system. And also in terms of data duplication, right?
Is it data normalization? Is it the one same as duplication?
No, it's not the same. What is data duplication?
I think it's where we duplicate records, where the system can allow us to create two records, two same records. The system should reject if you have got that same record, you are trying to enter it. Or
Yes.
maybe.
Yeah, that's true. So we are saying with a file-based system, you can capture a student more than once. But in a database system, it will not allow you to do that because a record is entered once.
Yes.
Right. What about in terms of data consistency?
Due to the data duplication, which is rampant in the file system, it causes data inconsistency in the sense that should a file or a record updated in one department or in one record and the other one is not updated, then we have data inconsistency.
Okay. All right. What about in terms of easy recovery?
It's not easy to recover a file, data in a file as compared to a database, because the database has got a very good way of backing up things.
Okay. What about in terms of cost? Which?
I think database implementation is quite expensive than file system. However, when it's implemented, the database system, it becomes cheaper than the file system. To implement, it's expensive, but when using it, its functions are even more cheaper than the file system.
Okay. What about in terms of privacy?
I think on file system there is no privacy, or there is no data integrity, what we call. data security. While it's on DBMS, there is much better data integrity or security of data.
How do we promote privacy in DBMS?
Isn't it the pathway we use in login details to get into a database?
Yeah, okay. Right. The issue of authentication, right?
Yes.
And authorization.
And authorization. And also the issue of access rights.
Yes, where we can
Okay.
say. Okay.
Sorry?
It's okay. It's okay. I think it has been said that it's okay. We can proceed. Okay, I wanted to say where we can say. I think it's the next.
Right, out of interest, I just want to understand which database engine are you using? Database platform. Are you using SQL Server? Are you using MySQL? Are you using Oracle? It's actually Financia.
It's Financia, yes.
Yes, please tell me.
It's
which database are you using?
It's an SQL Server.
It's an SQL Server. Okay. All right, then who else?
Yeah, myself, I think it's Oracle.
It's Oracle. Okay. So, yeah, that one with Oracle, you will tell us more. Right, who else?
I just think I was just okay, no problem.
All right, it's okay. It's okay. Let me. Right. Okay. Let us move on to the ACID properties in DBMS. Have you ever read about the ACID properties? Hello, guys.
Yeah.
You guys, you're letting me down. You're letting me down. Murikwero.
We are here.
Right.
Sorry,
So
sir,
the issue
I missed
is
the question, sir. I missed the question. Sorry about that.
Okay, it's fine. I said, have you ever read about the ACID properties of DBMS?
Yes, I think I've come across the word somewhere.
Yeah, so this one is a very, very critical area in a database management system, right? Even if you want to be a serious database administrator, or if you want to be certified with Microsoft SQL Server, or if you want to be certified with Oracle University for Oracle databases, you need to understand the ACID properties of databases. So to ensure the integrity of data during a transaction, the database must maintain the ACID properties. So the first one is atomicity.
Atomicity.
What is atomicity? Right, so, right, these days, I think many people can understand the issue of atomicity. Because what we are saying is that suppose you are doing a transaction from your bank to your EcoCash, right? Your bank balance is 1,000. Then your EcoCash balance, maybe it's 50 bond. Then if you transfer 500 from your bank account to your EcoCash wallet, right? Then if the transaction fails to update the bank account and updates the cash wallet, then it becomes a problem. Are we in agreement? This is an example which I just want to give you. What we are saying, you have got 1,000 in your account and you have got 50 in your EcoCash. If you take 500 from your bank, then you put to a wallet. Then if your wallet accounts give you 550, while if your bank is giving you the balance as 1,000, I said your balance is what? 1,000. Then it becomes a what? A problem. Obviously, another scenario, maybe we are saying it has deducted 500 from your bank, then the balance now is 500, but it doesn't credit to your EcoCash wallet, then the balance remains 50. Obviously, you will go to either to your bank or to EcoCash to ask what happened. So in essence, atomicity, we are saying whenever the transaction is happening, it must make sure that it's done to completion. Are we in agreement? Hello?
Yes, we are agreeing, sir.
So we are saying this property ensures that either all the operations of a transaction in a database are done or are not done. To say, if you are trying to take some money from the bank, if it fails to credit to the wallet, then it must also fail to debit on your account. But if it credits to your bank, to your wallet, then it must also debit your account. That's the atomicity account. It is to make sure that it is done to completion or it must fail to completion. That's atomicity. What we have understood.
Sir,
yes.
A question. I have a question. Okay. Maybe an example.
Yes.
Let's say I want to buy electricity, right? From my bank.
Yes.
Buying for someone the electricity. Then after having done the transaction, then my bank debits my account with the amount equivalent to the electricity which I would have bought. But then the person whom I bought the electricity does not receive the token to show that he or she has purchased the electricity. But is it what we are saying?
Yes. This is what we are saying.
Atomicity issue.
Yes, this is what you are saying. You said you want to buy electricity token for someone, then
Yes.
after buying the tokens, then the debit is done on your bank.
Yes.
But the credit is not being done to ZESA for that particular person to receive the tokens.
Yes.
So in that instance, we are saying the transaction should fail completely. That's the issue of automation.
Okay.
Hope you have understood.
Oh,
Someone
yes,
with another
I have.
example.
So maybe just a follow-up on that.
Okay.
So after some time, maybe after 24 or 48 hours, then the transaction reverses. So is that the issue of atomicity, that it should fail totally?
Yes, that's the issue of atomicity.
Okay.
Okay.
So when you go to the bank and before that time comes, or that time which they would have stipulated, you can come after 48 or 24 hours. They would say we cannot do anything because they will be waiting for that database to do that for them.
Yes, yes, because there is a issue of commit and
rollback. Yes.
Rollback, yes.
Okay, noted. Thank you, sir.
Right, then let us move on to isolation. Isolation. Right, so with isolation, we are saying the transaction should be done in isolation. Can someone try? This one is interesting. Can someone try isolation? A database administrators Muripa,
This goes on to the critic.
Can I try, sir?
Yes.
I just want to try. I think on the issue of isolation, we are saying transactions should happen independently. Let's say issue incomplete on that issue, gets here. It's incomplete, right? The next transaction that I would want to do should not be affected by the incomplete transaction of buying the ZESA tokens. That's what I think.
Right, okay, let me give an example. We are saying you want to buy electricity tokens for 2 people. And
yes,
right, then you want to buy for individual A maybe for 500, then individual B for 1,000. And so we are saying in your bank account, maybe your bank account has got $1,000, it's got 2,000, and you want to pay 500 towards A, then 1,000 towards B, which means your balance should be what? 500. And right. So we are saying the transaction should be done in isolation, because if you do, if this transaction executes at the same time, to say the 500 and the 1,000 is done at the same time, you will get the wrong answer, because the 500 one will update and gives you the balance of 1,500, and also that one for 1,000 will also execute at the same time and give you the balance of 1,000. So obviously you will get the wrong balance. So we are saying the transaction should do in isolation or independently to say, let me execute this transaction first. After I am done with this transaction, I'm going to execute this so that I get the correct what? Answer. Is it making sense?
Yes.
I think it is. Maybe this example, if I am correct, if let's say you want to top up your airtime.
Yes.
Then after having completed after having pressed that confirmation number, enter that confirmation number that you want to buy some airtime, as it will be processing that circle showing that it's processing. If you try to enter any other number, it will say it will reject, saying still something is being processed. Is that the issue of isolation?
Yes. So we are saying it is to finish another transaction first before doing the other one. So transaction must be done in isolation. So that one will also affect the consistency. So the consistency, that's the reason why I had to skip consistency, because we are saying consistency now can be maintained as a result of isolation. Because now you get to know, okay, this balance is the correct what? The correct balance. Right, let us move on to durability. What is durability? Right, an example which I can give for durability. Right, suppose you just want to transfer an eco cash amount to your mother, then you put the wrong number. What will happen?
The man will go to the wrong number.
Huh?
The man will go to the wrong number.
The man will go to the wrong number. So, yes. Are you able now to reverse it?
Yes, but through the service provider.
Yeah, so we are saying the durability of the transaction now, we are saying once a transaction completes successfully, the changes made to the database, are permanent. That's the durability. Whether you have done it to a wrong number or what, but the changes are permanent. So there will be need some interventions for you to reverse that. That's the durability aspect.
Understood, sir.
So whether you like it or not, the transaction has been completed.
Yeah. So so now with the durability now, it's once the transaction has been committed, it becomes durable, whether the system crashes or what. In an event that the machine, maybe the server crashes, but if you manage to restore that one, you will see the transaction because it's now durable. Whether you restart the machine or what, but you will still find that transaction in existence.
So how is it an advantage in the database management system?
Yes, this one is an advantage now. We are saying, right, if you make changes, the changes must be permanent. So that, because imagine you have transferred Okay, let me give an example. Which one? Maybe you have taken a bank loan and then they take the installment amount. Then that amount is not a durable transaction. Then it will suddenly come back to your account to say you haven't paid. Is it an advantage to you? So the advantage is that once the transaction is done, whether it has been done using a machine which is not stable or which has got some issues, but it becomes a permanent in the database setup. That one is an advantage. Are there any questions?
It's clear.
It's clear. Right,
Yeah.
let us move on. Right, I think this one it's simple. Let us quickly run through the environmental components of the DBMS. Right, by heart, what are we saying there?
These are the physical components of the database management system. For instance, servers, computers. I don't know if I'm correct. And
yes,
the network
those are
as
the
well.
physical components. Let us move on to software.
We'll be talking about the operating system, where the database management system are sitting on, as well as the application that manages the database and creates an interface between the database and the user.
All right, okay, let us move on to users.
I think the user personnel example na Venencia, the people who manage the it's an example.
Yes, the database administrators, the users as well. Like it's so schedule one. For example,
Okay, so the users and do bana Venencia ne bamweo andika. Right, let us move on to the data.
The raw information that is stored. The file.
Unprocessed information.
Saka data racho, for example, kwana Venencia tokubira example ye data ramunochengeta.
We store, we've got a great book where we record my assessment, my tests no recorder data, which we will process at the end of the term.
It's fine. So let us move on to the procedures. The procedures, please.
Algorithms.
Right, example procedure ichi. Muchiri kuelewane. Saka kana tisingazivi topfuura yada anditi. Because a procedure, woman, what is a procedure? What is a procedure?
Are we not referring to the algorithms which we use to manipulate this data? For us to get our output, we need those procedures.
Someone to try?
I was going to say those are the, I think they are the guidelines. Say when enter how we go about in managing, like if you want at the end of the day to get average scores, we have to start by updating the initial fields at the start for each student.
Right. So in essence, we are saying procedures. These are set of rules and instructions, and the way you. So, if you are at a workplace, obviously you need to come up with your procedures or rules that govern the way you operate. So we are saying the procedures now. These are the set of rules that will govern now the design of the database system. So my procedures, they involve that actual software.
For instance, how you log on into the database management system. So
there are procedures which, okay, how do we access the data in a database? Then you say, no, we need to give this guy as the administrator the overall rights, but this one should see the creditor side, this one should see the data side. Those are set of rules. Sorry, guys, I just want to pick this one. Right, sorry guys, let us move. Time is moving, hey. Right, database architecture. Right, okay. So the reason why I had to ask you guys to say, are there anyone and from IT? I think that was my first question, because I knew when it comes to database architecture, obviously I would need contribution from you guys. So, right, that guy, Oracle is what? Who is the name of that? The name is what? Ataura zveOracle ndiani zviya? Hello, guys. Hello, Mr. Dixon, are you there?
Yes, I'm there, sir. I'm not the one.
I'm looking for someone who, huh?
I'm not the
You
one.
are not the one. All right, it's fine. Okay, so let us move on to the database architecture. We have got a single tier architecture, then 2-tier architecture, then 3-tier architecture. So what is a single tier architecture?
This one now, this is where the client server and the database reside on the same machine.
Okay. Also, you are saying if you are running a a SQL Server database, you need to make sure that you install SQL Server database on that machine. Then, if you need also to install the database application on that same machine. And
yes.
Okay. What about the 2-tier now? So this one is the single tier we are saying. It's running on the same machine. All right, what about 2-tier? I think it's pretty obvious. Because we are saying 1-tier, okay? We have got one machine. So in this case, we've got 2. All right, the first one being a client machine. So which means client machine will represent the clients. There may be more than one client machines, then the other one becomes the server. So we are saying now, we need to have the database on another machine, and other client's machine will be accessing the database from another machine. Is it clear?
Yes.
Yeah, so we are saying we need to make sure that you install SQL Server on another machine, and then you make sure that you configure and design your database there. Then on the client machine, that's where you put your database application so that you'll be able to access the database. So the storage of the database will be done on the server and will not be done on the client machine. So that's the second tier. Let us move on to the 3rd tier now.
It's just an extension of 2-tier that we discussed about, and it combines the presentation and the database and the other one. Usually, the 3rd tier example of the 3rd tier extension of 2 clients, like a large website on the internet. We can just represent those are the things that we can include by 3-tier architecture: presentation tier, application tier, and database.
Yeah, I also agree, because there's the client, then there's the server, and then there's the database aspect of it.
Okay. All right, so you have mentioned the website, and what about if it's not a website? Can we have another scenarios where we will not be talking about websites, where we can use 3-tier in an organization? Because I can give an example, right? If you have got an ERP system, do you have ERP systems, guys, in your organizations? I'm not talking about Valencia in this case now. Hello? Could a ERP system?
My first time hearing about it, sir.
Whoa.
Yes.
Saka muchadzidza zvakawanda umo.
All right.
Yeah, both an ERP system, we are saying enterprise-wide system, a system for the whole organization. So it depends now with the type of an ERP system. It can be designed in such a way that the database will be on its own. Then there is an application which will act as a middleman to connect a client machine. For the client machine to be able to access the database, there should be an application which will be the online transaction application, which will act as the middleman. So the 3-tier now we are saying the user will not be able to be interacting with the database, but he can only be able to access the database through the application tier. So that's the, I think you have read this one because it was leading you to your assignment.
So just a quick one, sir.
Okay.
So on the 3-tier, we are saying we have the users. The users, probably it's me here. And for let me give us an example. I am a user of an Econet database, right?
Okay.
It's true, right? Because I can access my information about my line on Econet, right? When I request for balance and do some stuff like something like that. So I am a user, right?
Yeah, you are a user.
Yes. So we are saying there is me as the user. Then there is an application on my phone, which is allowing me to interact with the Econet database somewhere.
Yes.
So that's the 3-tier system.
Yeah, that's a 3-tier system. That's the reason why I said, because that one, of course, it will sort of work with website. Because you can either install an application on your phone, or you can even use an application on the internet to do the same. All right, but I'm saying the 3-tier can be in such a scenario, or within an organization, we can still have a 3-tier.
Okay.
So that's the reason why I said, okay, let us explain for if you have got an ERP system. As an organization, internally you can have a 3-tier, and the example which you have given us then is sort of external, but it's also a 3-tier.
Oh, okay. Noted, sir. Thank you.
Right. Okay. That was your assignment, huh?
Yes.
so obvious. I'm not going to talk much. You will be talking. All right. Okay. Explain to me that diagram.
The three-level architecture and the Spark.
Yes.
I want to give it a try.
Yes, yes.
The three-level architecture is divided into three, as shown on the diagram. We have the external level, the conceptual level, and the internal level. The external level is the level, is the user level, where the users, different users can view information on the database. Different users viewing same information on the database, but with different views. For instance, a user like me can view my balance in the bank, whereas the clerk in the bank can view something which I cannot view, and the database administrator for the bank can view what the clerk and me can not view. Then the conceptual level. This is the level where the data in the database is actually defined. That's what I want to think. Then we have the internal level, which is the physical aspect of the database. In summary, that's what I think.
So you talked about conceptual level.
Yes, the conceptual level is the what can I say, the logical design of the database.
All right, can you write? Of course, yes. On external level, yes, we have articulated that one very well. Because you are saying, obviously, the users will be interacting. But the reason why we are saying this one is necessary, because obviously we are saying the activities of users must be independent of each other. Then also the activity of database administrators should not affect users.
Yes.
And also the physical storage changes to databases must not affect the internal structure of database, and also must not affect the users. So that's the essence of this architecture. Because we are saying we have got the external level, the activities which are being done at the external level must not be affected by the activities being done at the conceptual level, and also must not be affected by those at the internal level. So we are saying external level, yes, users will be having different views as to the system. And we also need to understand to say there is also what you call an external scheme. Then we also need to understand the issue of the mapping, where we are saying there should be a logical, external or conceptual scheme mapping, as well as the conceptual or internal scheme mapping. We need also to understand from you what mapping is. Right, okay, so then we move on to the conceptual level. We need to understand the activities that are being done there, where we are saying, obvious, the database administrator will be working there, will be working on the relationships, the constraints, the validation, the security, and the recovery of the database. But while it's doing that, there should be some independence to say that those activities should not affect the users. Then we move on to the internal, where we are saying now, we are talking about the physical implementation of the database, where we are saying, no, right, what are the space requirements of this database? And what about the data compression, which we need to apply to this database? Then the storage sizes. And those activities should not also affect the other levels. That's basically the table is saying. So now, there is what we call data independence. Have you also talked about data independence?
When I was explaining.
Yes.
No, I did not.
So you need to proceed.
Someone can proceed, sir. Someone can take off.
Right, someone need to take off. Someone to take over, please. Because this one, and it's an assignment question, so I think you have done this one. All right, so by data independence, we are saying the uppermost layers are not affected by changes in other low-level layers. To say what's happening at the conceptual level should be independent of what will be happening at either the external or the internal levels. So there is logical independence, where we are saying changes to the conceptual level should not affect the external level. And also we have got the physical independence, where we are saying changes to the internal structure of the database should not affect the conceptual level. I think all given in that diagram. All right, so have you all submitted your assignments? You've submitted, right?
Yes, but
right. Are there any questions there? I think that we should not take much of the time.
The way you are laughing, say.
But I think the guy who tried, what's the name of that guy who tried to explain this diagram?
It's Dixon.
Yeah, the way you tried to explain Mr. Dixon on external level, if you also explained in that assignment for other levels, then you are good to go, because external level you have explained very well. Right, so we are saying that's our Spark architecture. Let us move on to data abstraction in DBMS. So we have 3 levels of abstraction, which is the physical, logical, and view level. So this abstraction, this one follows what we have done, because the view level, obviously we are saying, obviously the users is the highest level of data abstraction, where the users will be interacting with the database, and the logical level is the conceptual, and the physical level is the what? The internal. It's the same thing. Let us move on to this one. You have done also an assignment on that one. What is a weak entity?
Sorry, sir.
Yes.
Can I take you back just a little on that other diagram, the
Okay.
the unspark?
Unspark.
Yes.
All right.
On the issue of mapping, I'm having a difficult time understanding that issue on the mapping and schemes and stuff.
What are the challenges?
Not understanding it all. What exactly do we mean? Or what is
right,
it that
okay. All right, by scheming and it. All right, I'm happy that we have got database administrators here. All right. Whenever you are coming up with a database,
yes,
you need to define what you call a database schema. Right? Remember database amuri kuona uko makangwana aripo ere kana kuti
tikaona aripo
makaona. Saka now, saka database schema is the container, kala kuti the description of a database. Saka kala kuri ku Oracle, the database schema is the user anenge ane the overall right ye database, where we are saying if you want to do something on this database, you need to use this schema credentials. Then for SQL Server, we are saying it will be sort of a container. All right. So, for example, we have got what you call a DBO schema, but that's the owner of the database, or you can define your own schema. So, by schema now, we are saying it's just an overall description of the database.
Okay.
Right. Okay. So let me check something. All right. So I think in our next lesson, Kadarichi Rico, but chaita my relational databases and Pachata so create my database. We are creating a database, we are creating a table. I think I need to show you what the database schema is.
Okay.
Okay.
I'm saying because it seems as though the time is racing against us. Right. Okay, let us move on to. I've asked the question, a weak entity.
I think it's an entity which depends on other entities.
Okay. So can you give me an example?
Naumero.
So guys, you don't, huh? An example of a week ended.
Can I give an example, sir?
Yes.
I want to try.
Mm.
Let's say in an organization, and the organization might want to keep my information as an employee. Then maybe they would want to have the record of my wife as well as I don't know, as a next of kin or something. I think my wife will be a weak entity because her existence in the organization will simply be because I am an employee in that organization.
All right, yes. So we are saying in an organization and a dependent is a weak entity because it would depend on the what existence of an employee. So that's a weak entity. I think it's a good example. All right, even a room in a hotel is also a weak entity because it can only exist if there is a hotel. Or to say a room in a building.
Can only exist if there's a building.
Right, so let us on then, what is the key attribute?
I think it is the primary key of a table, which is used to identify a table.
All right, so how do we represent a weak entity in an ER diagram? I forgot to ask that one.
It is a double lines.
Double what? A double rectangle.
Border. Yeah.
All right, a double rectangle. Thank you very much. What about a key attribute? How do we represent it?
We underline it.
Right. What is the composite attribute?
This is when two or more attributes are used to identify a table or as a reference to a certain table.
You said what?
Okay, I said I think is when we use two or more attributes to identify a table.
Right, so we are saying, all right, I'm not so sure about your description. Maybe if you can give an example, it will simplify the matter. Can you give an example?
I'm still trying to figure out a good example. Unfortunately.
Can I interject?
Yes.
Okay, like I'm not so sure if it's going to be a perfect example, but I think an example is if we have got in a address attribute, in address attribute of a student entity, then your via consists of street or province, maybe house number, you can have state or country, something like that.
All right. Yeah. So we are saying an attribute composed of many other attributes becomes a composite what attribute? For example, address, because if we say address is an attribute for a location, but now it has got also other attributes. For example, maybe to say city, the street, and the country. So it becomes a composite. Then what about a multi-valued attribute?
I think this is whereby we will be having an attribute with, maybe I can explain it with an example.
Yes.
A person can have multiple phone numbers. So an attribute, phone number, when said to be a multi-valued attribute, it will be having more than one phone numbers. That's what I think.
Yeah. So it becomes an attribute which has got more than one value. For example, phone number. How do we represent it on a graph?
Sorry, I didn't hear the question. Sorry.
How do we represent the multi-valued attribute on an ER diagram? ER diagram.
In over with double lines.
Okay. All right. What about a derived attribute there?
It can be an attribute derived from other attributes.
Sorry, sir.
Yes.
I think I was wrong there on the multi-valued attributes. After having heard the description of it, that is an oval shape with 2 lines, then I was wrong.
Why are you saying so? Because a multi-valued attribute is represented by a double oval. Mr. Dixon? Hello? Am I having people here?
Well, yes, we're following.
Because it's okay, it's okay. So we are now on a derived attribute. What is a derived attribute?
A derived attribute is an attribute whose value can be determined by another attribute. For instance, if you age, let's say age can be derived from date of birth. So age will be a derived attribute.
Okay, so how do we represent it on a graph?
A dashed oval.
Ah, okay. All right, so let us move on to one-to-one relationship. What is one-to-one relationship?
This is a relationship. There will be only one and only one relationship between two attributes. For instance, only one person in Zimbabwe can have one eco-cache line.
Yeah, after that instruction to say we are going to close, or because I remember at some time people would have more than one.
Yes, but still, I think I still think it's not a good example, because eco-cache lines eco-cache can have many users. I don't know.
I thought you would say one Zimbabwean nationality has got one ID number. Are they end with two?
No.
But obviously we cannot consider Batsotsi, but but Matsotsi anenge aripo anotova ne2. All right, so what about one-to-many?
One teacher teaching two or more subjects.
Right, so how do we represent it on a graph?
That we have the teacher is the attribute, and then subjects, and then you'll have three, what are they? One to many. How can I describe?
It's okay. It's fine. It's fine.
Yeah.
Right. What about many to one?
Many students, one subject.
Many students, one subject. What about many to many?
Many lecturers teaching many students.
Right, okay. My question to you now. If we are serious with database administration, do we have many to one relationship? Please, I need an answer. I need an answer. Huh? Do we have many to one? Umanaka, panas nombutaurera. Panas nombutaurera. Anonzi toko. Right, Mr. Dixon, Jimanga Mshimboedzaka.
I don't know say apaninganye passion.
Right, okay. In personally, I don't subscribe to a many-to-one relationship. Why? Because obvious, I stand with one-to-many. Why is it not one-to-many? Right, so if you want to do certification for SQL Server, they would say, no, there is nothing like that. You can get that one from literature whenever you are reading database administration. But when we do the actual database administration, there is nothing like that, because many-to-one is just one-to-many. So do you subscribe to my assertion then? Yeah? Do you agree with me?
Maybe we can, if we can have an example of one-to-many and many-to-one and see if it's one and the same thing.
All right, okay. One-to-many and it, right, from the example given by Valencia, I said one teacher teaching many students. Then using the same example, I can say many students and it taught by one teacher. What's the difference then?
There's no difference.
One teacher teaches many students. Many
yeah,
students
it's one
taught.
Being taught by one teacher.
The only difference is the literature. Yeah, that's true.
So that's the reason why because I don't subscribe to it. Right, okay, let us do, I was not so sure kuti maka submit my assignments. It didn't get example yenyu ya makaita. But kana tine example anayo someone would read after this one to vachambunaki was ne assignment. All right, so can someone read there so that we can come up with the entities, the attributes, the relations? Can someone read?
Design a database for a bank, including information about customers and their accounts. Information about a customer includes their name, address, phone, and social security number. Accounts have numbers, types, for example, savings, checking, and balances. Also record the customers who own an account. Draw the entity relationship diagram for the database. Be sure to include arrows where appropriate to indicate the multiplicity of a relationship.
Right, okay. So let us now come up with entities.
Customer.
Right, customers.
Customers.
Account.
Then the next one.
Accounts.
Yes, accounts. Right, what else?
We only have two entities here. I think so. I want to believe so.
All right, okay. So what are the attributes of customers?
Hello.
The name,
address,
Right, name, address,
phone,
phone, then social security number. So from that list, we need to understand it. Primary key which
SS number.
SS number becomes our key attribute, right? All right, so do we have composite or multi-valued or derived attributes from there?
Yes, name.
Name is what?
Name is a multi-valued attribute. You can have a first name and surname.
Right? So we need to indicate that. What about address?
Street number.
Then phone number is what? That phone.
multi-valued attribute.
Multi-valued attribute. And okay, so let us move on to the next. For accounts, we have got numbers, types, and what? Balances, and
yes.
Then from there, do we have derived attributes, multi-valued, composite, and also key attribute? Key attribute is what?
Phone number.
All right. Then what about
balances? We can have credit or debit balance.
it becomes what? What about types? Types is what?
Type is a multi-valued one.
Savings, checking.
But can we say it's a multi-valued one? Because maybe only one person can have just a savings account or checking account. So I don't know. Can you say it's a multi-valued attribute?
In a type, I just want to believe it as composite in this case. Both type. Let us debate on that one.
Because I want to believe that a multi-valued attribute, right? It's an attribute like that, like name. It's a multi-valued attribute because there is no person who just have a first name and doesn't have a surname. But someone can have a savings account and not have a checking account. I think type is just an attribute. Then savings will be the field of that attribute.
Savings becomes a what? An attribute of that attribute.
No, I want to say a value of that attribute. It will be, savings will be value of that attribute type.
Okay.
Yes.
Right. So let us move on to the relationship.
A customer can have many accounts.
A customer can have many accounts. What else?
Yes. An account cannot have more than one customer, but it can happen.
What about customers to accounts?
A customer can have more than one account.
So it's one to many.
I don't know if it is not possible for an account to have many customers. Like maybe it's a family which is using one account, and or it's a school.
Okay. Let us talk about a joint account.
Yes, a joint account.
So, which means many customers can have one account.
Okay.
So, if you are given such a question, how are you going to do it? Saga, under such circumstances. Hello.
I'm sorry to interrupt. I've just joined the meeting. I wanted to ask, are we on the topic on how to draw entity relationship diagrams?
Yes.
I think it's a.
Where have you been since 11?
We did not have electricity where I stay in Vutikaroy. So electricity supply has just been reconnected. We didn't have electricity since yesterday.
Oh, I'm very sorry for you. But anyway, we have managed to join. Whilst we are almost finishing because it's now 2 to 1. But anyway, can you just tell us your experience with database systems?
Okay, what I know about database is that it is a collection of related records which can be accessed on a single platform. They are what we call we have data.
Right. Okay.
So maybe into the.
Maybe my question is not specific. Maybe my question is. I don't want you to tell me about literature. I'm saying your experience with database. If you, maybe from where are you working right now?
I mean,
do you use databases?
I use a Microsoft Access.
Microsoft Access at work?
Sometimes.
All right, it's okay. Yeah, that's the reason why mauya kuzodzidza mukuru wangu pakaroya. Microsoft Access, hatichaidi kuinzwa izvo. Tauda kuti mufambe nebhora muchipinda mumadatabase mamwe ari nani. But anyway, thank you very much for joining. Right? Is Mr. Marufu still online?
Thank you for having me.
Oh, okay. Thank you. All right, I'm still trying to locate Mr. Marufu. All right, because this session, I'm told it was supposed to be for 2 hours. But still so I just want to find out from him if we still have another session in the future, or this is the first and last, because there is still more to cover. And from the look of things, we haven't yet covered database systems.
Yeah.
The practical sessions. So let me try to get hold of Mr. Maruf, then I'll update you. Right, hello guys.
Hello, sir.
Right, I have talked to Mr. Marufu, then he said the session was supposed to be 2 hours. So now we are supposed to conclude this session. So are there any questions before we close? And he said he's going to arrange another session where we are going to cover the rest of other topics. And also another question to you. All right, you need to tell me the convenient day. Is it weekend or midweek?
I think weekend is, I don't know with the others, but I don't know, but weekend.
For myself, weekdays are okay.
Weekend.
Yeah.
Weekdays is, if it is from maybe from 12, because we'll be busy from morning until.
All right, so who is the
unfortunate part is that some of us will use the network at work. So weekends we are not normally at work, and data is quite expensive.
Yeah, it's okay. So right, so we are going to do midweek, but I think we need to agree now on the convenient time. Is it morning or afternoon?
Afternoon.
I think afternoon will be okay.
Afternoon, I think will be fine.
As from what time? Because I just want to update Mr. From 12.
From 12, yes.
It's okay. All right, so are there any questions before we close? Right, I've shown you my contacts. If you feel that you need to ask something outside the scope of this lesson, those are my contacts. You are free. And if you are in Wange, you can as well also, if these days, whether you are in Karoi or you are in Wange, you can as well engage me, and we can have this interactive session if you feel that you need to understand something.
I have a question there.
Okay.
My question is, I'm still trying to register, like I did all assignments, but not yet registered. So I hope maybe that is it submission button, how long would it gonna take on the portal? Because when it's disappeared, I'm not going to submit. Yeah, I have this challenge to register, but I'm still on the process to do it.
Also, you are still on the process to register?
Yes.
That one is not a problem. You need to, if you find problems, just engage Mr. Maruf. He will be in a position to assist you.
All right. Thank you so much.
Yeah.
What
yes.
I was listening all along in this lecture, but one thing for sure, I'm just one of those people who are interested in IT, but I don't have that strong background. I surely need your assistance, and surely I want to thank you for this session, but basically I did not get anything. I only have that literature from that individual when we're saying you give literature only. I don't have the basics on hand.
Yeah, it's okay. So, all right, in our next lecture, we are going to navigate the actual database. I'll connect on my machine the actual database. So we will be creating the database, adding a table, and do what other practical issues. But like I said, if you feel that you still need to ask other issues, you can ask outside the scope of this lesson. And if you want to send an email, it's up to you. If you want to send a WhatsApp, it's up to you. I will be able to assist you guys because it's my passion. It's my passion.
Thank you.
Yeah, because if you look here, right, this is SQL Server MCSE, this one. It's Microsoft Certified Solution Expert in SQL Server, and this one is Oracle by Oracle University. That's the associate, Oracle associate. So, these database issues, I'm interested in them. So if you have got questions, please feel free to contact me at any time.
Thank you very much.
Thank you,
Right, so
sir. We will.
If that, sorry. So if there are no any other questions, guys, it's bye-bye for now.
Thank you very much, sir.
Thank you.
How about the recording?
Thank you, sir. We'll keep in touch through the information that you gave us, your contact details.
It's okay. So I will give the recording to Mr. Marufu. He will be able to share with you guys.
Okay.
Okay, Jangi.
Okay, thank you, sir.
All right, thank you.